Hello, my dear students. Today we will perform an experiment which you can do at your home also. Side you can see is blunt one, and this is a sharp side. Okay, and this is an apple, right? Now, if you try to cut this apple with this blunt side, you will find it difficult. It is very difficult to cut this apple. But when you take this sharp edge, and then you can cut the apple very easily. You know why it is happening? It is happening due to a phenomena, due to some property of physics. Okay, so let's discuss all these things in detail, and let us take some more examples which you have seen in your daily life, but you actually didn't know about the physics or science behind that. Okay, so actually this is what we call as, there are two terms. One is thrust and other is pressure. We will be doing these two terms, and when we understand these two terms, we will be able to understand why it was very difficult to cut the apple with a knife having blunt side, and it was very easy to cut the apple with a sharp edge. Okay, I'll give you one more example. Like if you have a nail, okay, the iron nail, and you have to put it into the wall, then you will use the pointed end. Okay, you cannot do like this, you have to do like this only, because pointed edge will go easily into the wall. Why? Again, there is some physics behind it, and you will be surprised to know that behind all these two phenomena which I told you today, there is only two things. One is thrust, and other is pressure. Let us find a relation between these two. And before going into the detail of relation between these two, we must be knowing what is thrust and then what is pressure and how they are related to each other. Like, so this one is today's lecture. So very warm welcome to all of my students and the viewers in the today's lecture. And I will actually I can imagine that after viewing this lecture, you will be able to understand deeply about the physics behind the day-to-day phenomena, like which are using the property of thrust or pressure or all. Okay, to understand the physics behind thrust and pressure, let us take one simple example. There is a heap of sand, loose sand is there. Okay, and you put your foot on the sand and press it, you will see that your foot will go inside the sand, right? Very simple. Let's make a diagram for this for the better understanding. Say this is heap of sand. This is loose sand. And this one is you. Okay? This is your foot. When you applied force, the perpendicular force on the surface of the sand, your foot was just pressed inside the sand, right? It's very easy, very simple to understand. Now, let us take another position. This is sand, same structure. Now, you lie down on the sand. So, this is your head, and this is your body and legs. Okay. Now, this whole body is putting a force. You know what type of force the foot is making on the sand? This force is nothing but your body weight. What is weight? I told you in last lectures that weight is nothing but it is the force with which a body is attracted towards the center of earth. So weight is nothing but force. So it means the whole weight of the body is the weight, is the force which he is applying by his foot onto the sand, so that his foot goes into the sand, right? Very easily. But in this situation, when you are lying down, when you are sleeping on the sand, you can say, then you see that your whole body, which is in contact with the sand, is putting a force on the sand level, sand surface. Okay, this perpendicular force, you can see when you're applying like this, your body do not go inside, like this foot goes inside the sand. But in this case, your body is not going inside the sand. So there must be something. There must be something with the area. Because now what is this? This is the body. So body has a force. Body is applying force. And this force is coming from weight of the body. And this force is coming from weight of the body. So in both cases, force is same. Whether you are standing on the sand or you are lying down on the sand. In both the cases, the force applied on the sand surface, top surface, is the weight of your body. But what is different here? This much is the area of contact between your body and the sand. Here, only this much is the area. In which case, area is more? This case. In this case, the area of contact between the body and the surface is less. In this case, it is less. So, this perpendicular force applied on any object is called as thrust. Thrust is nothing but perpendicular force applied on surface of body or surface of an object, right? So, in this case, we saw another parameter other than force, and that was area. This is the area. This one is the area. Now, I will tell you what actually happened. There is a relation between thrust and area, and that relation is called as pressure. When we divide thrust by area, you get pressure. It's very simple. So, thrust per unit area is known as pressure. Now let us consider this example again, right? Then you will come to know what actually happened here. It's very easy. In this case, when the person was standing on the heap of a sand and he tried to put pressure, he tried to apply force on the sand surface with his foot. What was the area of foot? 10 centimeters square. Okay, this was the area of the foot, very small area. So area is small, right? When area is small, mean denominator is small. Okay, when denominator is small, the whole thing becomes large. That you know, because force mean thrust. Thrust is nothing but force. I already told you the perpendicular force. Force is same, thrust is same. Whether you are standing or you are lying, it is your weight of the body. This force is nothing but weight of the body. So pressure is nothing but thrust upon area. In this case, area is less. When area is less, mean denominator is less. And when our denominator is low, the whole thing becomes high. You know very well. So it means in this case, pressure is more. And when pressure is more, your feet will go inside the sand. Okay, now in this case, area of contact is high, is large, not high, is large. When area is large, pressure will become less. So here, in this case, pressure is less. And when pressure is less, your body cannot exert so much pressure that your body goes inside the sand. Like your foot goes inside the sand, your body cannot go inside the sand because of area of contact of the body and the sand is very large. And when area is large, denominator is large, pressure will be small, right? You're understanding this thing. Then when denominator is large, total thing becomes small. So what we learned today? We learned that there is something other than thrust which creates a problem, and that is nothing but area of contact between the body and the surface. If the area is small, pressure is large. If the area is large, pressure is small. So in this case, when you are putting foot, the area of foot covering the sand was very small. Pressure area is small, pressure will be large. And due to large pressure, your foot will go inside the sand, right? But in this case, your body cannot go inside the sand, cannot exert so much pressure. However, the force is same, your weight of the body, but what is different? Area. Here area is large, that is why pressure is small. Now, this phenomena was actually happening inside the first experiment which I showed you. What I showed you? There is an apple, right? Now this apple, when I cut this apple with a sharp edge, let us say this one is a knife and this one is blunt edge and this is sharp edge. Now, what is sharp? Sharp means it is thinner. When it is thinner, the area of contact between the apple and the knife will be large or less? Less, because it is thin. Area will be much smaller, and if area is much smaller, then pressure will be large. So you can cut the apple easily, right? But in opposite case, when it is blunt, mean it is thick, and when it is thick, it means it is covering more area, and when area is large, pressure exerted by the knife on the apple will be small because the area is large, thickness is there, so it means pressure will be less. That's why you cannot cut the apple with that portion of the knife. Very simple. It's very simple. Okay, take this example of nail. Let us suppose this is a nail. Okay, nail, iron nail, which you are using to put the, like this is hanged. So we are hanging it. So we need some sort of nail here, okay, or a screw here. So nail or screw have this type of edge, like very sharp edge, and this type of edge, which has more area. Sharp edge has very small area. So when the area is small, like this dot, okay, and this one, now this one mean this area. Which area is small? This area. These are the two examples. This is a example of nail opposite side, and this is nail sharp side, okay, pointed side, sharp point. So this is point, right? You can see that if it is a nail, it is a pointer size, and this one is having a large cross sectional area. So this point size has a small area. When the area is small, pressure will be large. So when you will use like this a hammer, it will go easily into the wall because of high pressure due to low area of contact. But when the area is large, you cannot do like this. You will be called as some stupid. You might have seen a movie, Bajigar. Okay, in that movie, there was a servant who's I actually don't remember his name, but he played the role, a comic role. He was a servant there, a cook, and he was doing like this in a scene. That he was not doing like this, he was doing like this. He was putting the nail into the wall from the opposite side. Okay, again, physics is there. You can see physics in your life. Physics is life, actually. Physics is love, right? So I think you understood this phenomena. Very easy. Okay, so we will take one more example, which is a kind of numerical problem given in your NCERT 9th class book, by which you will understand what actually happens when we increase the area of the same thing. Like if I put this marker on the earth like this, what will be the what will be the pressure exerted by this marker on the earth when it is put like this, and what will be the area of this marker when it is put like this in a lying position? You will be given some sort of numerical problems on this, right? So one numerical problem we will take. So the numerical problems which I was discussing with you is from the NCERT book of 9th class physics. It's very easy and simple, that you have been given a block like this. This is a block, right? This one is a block. This block is kept on a table. Say this is a table. Okay. And this block is also kept on this table like this. So this one is the vertical position of the block, right? This one is the vertical position of the block, and this one is the horizontal position of the block. We have taken a block and we put this block on the table. First case in a vertical position, and in the second case in the horizontal position, right? Very simple. Let the dimension of the box is like this one is 40 centimeter, say length, and this one is 10 centimeter, okay, and this one is say 20 centimeter, right? So in this case, this will be 40, right, and this will be 20, and this will be 10, right? Very simple, nothing complex thing is there. And we are given that in two boxes, in the two cases, box are same. First case, we are putting the box like this, okay, vertically, and in second case, we are putting the box like this. That's nothing new. Now, it is given that mass of the box is 5 kg. How much? 5 kg, right? So, what will happen? What will be the pressure exerted by the board on the table in first case? What will be the pressure exerted by this same board when it is kept in a horizontal position on the table? Then what is the pressure exerted by this box on the table? In both cases, we have to find the pressure. So in this first case, we will do here only. Let us find force, because pressure is nothing but thrust per unit area. What is pressure? Pressure is equal to thrust per unit area. That you know very well, right? So what is thrust? Thrust is the perpendicular force applied by the body on the surface. What force this body is applying on this table? That is nothing but its weight. Okay, when we are standing like this, we are putting a force on the earth, and that is nothing but our weight, which is perpendicular to force, which is a perpendicular force on the earth, and it is nothing but our weight, right? So the weight of this box, this block, is nothing but the force applied on the table in perpendicular direction. So let us find this. Thrust in this case will be equal to, what is thrust? Nothing but force. Force means weight. Okay. It will be equal to m into g. What is m? 5 kg. Right. And what is g? 9.8. For simplicity, we can take it as 10 also, right? Force calculations. So 5 into 10 equals to 50. So it is 50, right? Force is 50. Clear? You can denote it as Newton, 50 Newton, right? So now what next? When we have find force mean thrust, what is left? Area. Okay. What will be the area? Area. We will not take the whole area. We will take only this much area. Look at me. This much. Why this much? Because only this area is in contact with the box. I told you, when you're taking area for pressure consideration, you will take only that area which is in contact with the, suppose I have to take the area, I have to find the pressure exerted by this pen marker on my hand. Okay, then I will take the area, this one area only into consideration, not the whole area, like full area. No, only this much area which is in contact with the surface on which it is kept, right? So only this area we will take. What is this? 20 and 10. So it is a rectangle. 20, or it will not be 2. Naturally, we will have to take centimeter square. So 1 by 100 and 1 by 100, right? So it will be 2 by 100. Okay. 2 by 100 is 0.02 meter square. So area will be 0.02 meter square. Now find the thrust in this first case. So thrust will be, sorry, pressure. The pressure will be equal to, thrust is 50 upon area is 0.02. Okay, so you can put 100 here. So 50, it is 2500, right? 2500 watt. You call it as like the, what was the unit here? It is Newton. And what is unit here? Meter square. So Newton per meter square. Okay. You can also call this unit as Pascal. What? Pascal. Pascal is the name of the scientist who introduced the term pressure, Blaise Pascal. And after his name, to give him honor, as I earlier told you, that to give the honor to a scientist, we put the name of the unit. And it is nothing but 2500 Newton per meter square or 2500 Pascal. It is the pressure exerted by this block on the table. Let us find in this case. Again, thrust will be same, because thrust is nothing but the force, and force is nothing here but the weight of the block, and weight will be equal to mg. What is m? 5. And what is g? 9.8. We approximately take 10, so it is 50 Newton. 50 Newton is the force or the thrust or the weight of the body which is acting on the surface. Now take area. What is area? This much only. This much area. This much. Okay, not all area, because this area is in contact. We take only that area into consideration which is in contact with the table. So again, 40 into 10. 40 into 10. That is 400 centimeter square. Okay, 400 centimeter square. Now we will convert it into meter. 400 into 1 by 100 into 1 by 100. It becomes meter square. So 4, it is 0.04 meter square. So pressure in this case will be equal to 50 divided by 0.04. So it will become 100, and so it is 1250 Newton per meter square. So you see that in this case, when the body was kept like this, okay, when the body was vertical, what was pressure? 2500. And in this case, pressure is 1250. Can you tell me why it is so? It's very easy. In this case, the area of the contact between the box and the table was very small, 0.02 meter square. Area was small, that is why pressure was large, 2500. In this case, area was 0.04, double of this area. So in that case, the pressure becomes half. So it is clear that when the area becomes large, pressure becomes less. So in second case, pressure is less. So there is direct contact between thrust, mean force, the perpendicular force, and the area. Okay, force is same. What is different? Area. And that different area creates so many new things in your life that I told you. I gave you two to three examples in this lecture. And what did you see? You just found out a result that the pressure exerted by any body on another body only depends upon the area of the contact between the two bodies. If area of contact is less, pressure will be large. If area of contact is large, pressure will be less, right? So thank you very much for watching this video, and I would request again to subscribe my channel if you are new to my channel, and please share it with your friends so that knowledge can flow from you to them also. Thank you very much.